Okay, be quiet. Be quiet. Be very quiet.
College stories.
Be very quiet. Not yet. One more thing between us and college stories. If you're very quiet, you can hear me teach this next thing. Okay? So, 5 kilograms, right? We've got 5 kilogram mass. Okay? And there's 35 newtons of force, and it's like a mass. It's like a mass on a string. Okay? And the 35 newtons, when we talk about the tension, that just means that it's the force exerted by a string. So in this case, if it's hanging on the string, that's a force, an upward force. There's a 35 Newton force acting on this. Now, is that the only force acting on that?
No, gravitational.
There is a force of gravity. Okay, some classes will go the longest time. It's like, what is the other force? It's gravity, and we know how to calculate it, right? So one of these forces, be quiet. Please be quiet. Stop. One of these forces in a vertical problem could be weight. Now remember, weight is m times g, where g is 9.8, right? So if you ever have a vertical acceleration problem, the first thing to do is to calculate, if they give you the mass, right, is to calculate the weight of the object. And remember, 5 kilograms is the mass, it's not the weight. The weight is the force of gravity, right? So 5 times 9.8 is a force downward, right? There's 49 newtons down, and then since it's downward, I'm going to make it negative, or some people like to make it like that's negative 9.8. That works too, right? Okay, but you know, at the end of the day, and before we actually go to the next part of the problem, this force has to be negative, this guy has to be positive. Which way is it going to be accelerating? It's going to accelerate down. Now that doesn't mean it's moving down. That just means it's accelerating down. So it could, if it's sitting still, it could be that it's starting to go down, right? Or if it's moving up, it could be that it's stopping, right? If you stop moving up, aren't you accelerating down? Yes? Okay. So let's set this thing up. All the forces are 35 positive, right? Minus 49. And that's all the forces, yes? Guys, hello? Right? So those are the two forces. We got a force up, force down, right? Okay? So it's always, by the way, these things always look the same way. It's always some force, the tension, right, minus the weight is m times a, right? So this is 5. And then in this case, it's the acceleration we don't know. Okay? No, it's not, because it would be if we cut the string, right? But it's not, because it's going to be less than 9.8, because it's actually exerted, there's actually an upward force. So 35 minus 49. So in these kinds of problems, you want to do the adding and subtracting on one side first, right? That equals 5 times a. And then we divide both sides by 5. And we get negative 2.8. So all we know is this, is that it's accelerating down. It doesn't mean it's moving down, right? You can accelerate down two different ways. You can either start moving down, or you can stop moving up, right? Now, if you're in an elevator that accelerates down, you can feel it, can't you? Yeah, you can. If it starts moving down or stops moving up, don't you feel a little bit lighter in the elevator? Don't you? Yeah, if you look at this situation here, right, that force upward is less than the weight of this object. Right? So in an elevator that's accelerating downward, which this thing is, right? The force that the floor, instead of the string, right? Elevators just push on our feet, right? That force pushing on our feet is less when the elevator accelerates down. So when it starts moving down or stops moving up, what do? How many people jump on elevators? Is this just a physics teacher thing? Yes, there we go. Now be very careful. After I told this story, I had some kids go, like 4 or 5 of them. They went and they actually made an elevator like go into fail-safe mode, because all 4 of them jumped on the elevator. And the elevator like was in the wrong position, and it shut itself down, and they had to get like some building supervisor. Okay? But here's the story I will tell.
We're still going to do this.
Like in Die Hard?
Here is the story I will tell. Okay? Is that I was on an elevator. This was at some IB conference in, like, I want to say Phoenix. Okay? And my story. Okay, and I'm in this elevator, and it's like IB conference, and I'm all psyched up, right? And the elevator, okay, starts to go down. And I decide, hey, I'm going to jump. Let's see how high I can jump, right? Well, it turns out that I can't jump very high normally, but in that elevator, I could jump sufficiently high to ram my head into the ceiling of the elevator. Yes? I went, whee, and when it started to go down, I went, boom, like that, rammed my head into the ceiling of the elevator. No. And then it stopped at the next floor. Like it almost stopped almost immediately, right? And I like land on the ground kind of heavily because when it stops going down, it's accelerating up and you actually weigh a little bit more. We won't get there yet, right? Okay. And I'm standing there in the elevator and it's one of those things where you cut your scalp and sometimes scalp wounds bleed like crazy, right? And sometimes it's just like a little bit of blood, you know what I'm saying? Right? And I'm just like, is that a gusher? Because it felt like it might be, right? So I reach up on my head and I'm like, like it's a little bit pink, but it's not blood, it's not real dark red. It's just like a little scratch, right? And some nice guy, kind of a roundy, middle-aged guy with a briefcase, he chose not to get on the elevator. Because there was some guy standing there like trying to see, is my scalp bleeding, right? That's always like a danger sign, right? Is my scalp bleeding? I don't think I'll get on. I'll wait for the next one. Where are we? This one. Yes. All right. Let's try some of these, shall we? So, on all these problems, here's what you're going to do. When I give you the mass, multiply the mass by 9.8. That's a force that's down. Yes? Times 9.8. That's going to be the force that's down. Right? And then look at the force that's up, and then you're going to set it up. Right? It's going to be force minus weight is m times a. If I tell you the a, then it's the force you don't know. Yeah? Okay? Let's try this. Draw a free body diagram. There's a free body. All right. Look how fast you're learning. Try that one. 100 newtons up.